Hey guys, today we're going to take our last set of notes for chapter 4, and it's all about dividing with fractions. So we're going to actually cover 3 lessons, and it's all going to be dividing with fractions. So we're going to have combinations of fractions and fractions, fractions and whole numbers, and also a combination with mixed numbers. And the reason why I'm putting all those 3 lessons together is because the notes never change. What changes is just, oh yeah, well now you have to look out for this, or you have to do that, okay? So, but the steps are always going to be the same. So let's start with those. Now what's going to be interesting is that a lot of these notes you've already heard before. They're very similar to multiplying with fractions, but the only thing that's different is we have to do a little prep step to change it from a division problem to a multiplication problem, and voila, we're ready to go. So let's start with the first step. We're going to go ahead and start just like we did with multiplication. Must have 2 fractions. Okay, so again, that means if we have a whole number, we're going to convert it to a fraction. We're going to give it just a denominator of 1. So if we had something like 15, we would write it 15 and then over 1. And then it would be a fraction. The other option would be if we had a mixed number. What's interesting with mixed numbers is we involve all of the numbers. So we're going to convert to an improper fraction. So if we had something like 3 2/5, remember how we work this? We start with the denominator and we multiply up towards the whole number, so 3 times 5. Actually, let me try that the other way. 5 times 3. And then we're going to add the numerator, plus 2, and then the denominator will stay the same. So we get 15 plus 2, or 5 times, where am I today? 5 times 3 is 15, plus 2 is 17, and so I get the answer is 17/5. Okay? So again, gotta have fractions. If we don't have fractions, we need to convert them. Okay, here comes the next bit. Technically, we don't divide with fractions, okay? So we're going to change it to a multiplication problem, but we have to follow a path where we do something to each of the items in that multiplication problem, okay? Or I should say in the division problem. So first, we get to do nothing. Do nothing to the first fraction. So it stays the same. Now, remember, we've already, if it was a whole number, we changed it into a fraction. If it was a mixed number, we changed it to an improper fraction. So we already have fractions. That's all we have. Okay, so that's the first step. Nothing. I like that being a first step. Next, we have to change the operation. So we're going to take division, and it's going to become multiplication. So the division symbol is going to become a multiplication symbol, or it might be the dot symbol for multiplication. Okay, now, there's no way that anybody could think that it's reasonable for us to change an operation but not do anything to the third one. Remember what I said? We had to do something to each of the parts. of the division problem. So we're going to take the reciprocal of the second fraction. That's a big word. Got to understand what it means. And reciprocal basically tells us flip the second fraction. Okay, so I'm going to give you some examples of that. So let's say you have 1/2. If you take its reciprocal, the 2 goes on top and the 1 goes on the bottom. So 2 over 1 is the reciprocal of 1 over 2. 2 over 3. Well, that becomes 3 over 2. 3/2 is the reciprocal of 2/3. Now notice I'm not using an equal sign because there's no way that anyone would say 2/3 and 3/2 are equal. So I do have a mixed number, so I'm going to convert it to an improper fraction. These two are equal to each other. So I get 2 times 1 is 2, plus 1 is 3, so I get 3/2. But if I want to take the reciprocal, then I flip the improper fraction, and I get 2/3. Okay? Now, what's something that guarantees that I've done this correctly? Well, we have a rule about reciprocals. If I multiply reciprocals, I always get 1. So I 2 over 2 equals 1. I have 6 over 6 equals 1. I have 3/2 times, 2/3 is 6 over 6. That equals 1. So when I multiply reciprocals together, I get 1. Okay? So I'm just going to tell you the name of this. Okay? It's the inverse property of multiplication. And it states multiplying reciprocals, which is its common name, and we would say multiplicative inverses. That's its formal name. That's why we like using reciprocals. Multiplying reciprocals always equals 1. Okay? Next, what do? Well, now we just have a regular multiplication problem. Okay, so how do we solve a regular multiplication problem? Well, we try to pre-reduce. Any numerator to any denominator. If it's straight across, you've done it wrong. And I know sometimes it's so tempting because it looks like you can cancel, but nope, can't. Okay. Pre-reduce, or you can wait to the end, which you always have to look, and then you just multiply straight across, just like we did with multiplication. So numerator times numerator, denominator times denominator. So I'm going to abbreviate num times num over denom times denom. I don't know about you, but I get tired writing all these big numbers sometimes. Yep, that's just me. And then the last thing, I've already done number 6, number 7. Always reduce the final answer. If possible. Now, if you did a good job pre-reducing, then there wouldn't be anything left to reduce. If you left something out, let's say like a stinky 3, then you still may have something you need to reduce. And again, we talked about before, reducing does not mean converting to a mixed number. That's optional if it's a regular math problem. It's not optional, though, with a word problem. So you can convert, or you have to convert. So I'm going to put over here, must convert improper to mixed number. So improper fraction to a mixed number in word problems. Okay, otherwise you don't need to. So let's go ahead and we're going to do a couple of different examples. Let's see. Directions are going to ask you to, I'm going to do an easy one. Find the reciprocal. So if we're given 1/7, our answer would be 7/1 or just 7. Okay, so we generally don't leave an answer with 1 in the denominator. If I have a whole number, the reciprocal, first off, let me change this. We're going to make it a fraction. Then we'll take the reciprocal. So the final answer is 1/4. Okay? All right, now we're going to do a slew full of division problems. So those sets of directions are just going to say divide. Now I'm going to tell you that the book doesn't always tell you to simplify the answer. Why? Because you always do it. Okay? Yes. So we've got whole number divided by a fraction. So first thing, we're going to rewrite the whole number as a fraction, giving it a denominator of 1. We're going to change the operation to multiplication. And then we are going to flip or take the reciprocal of the second fraction. So then we're going to look to see if there's anything we can reduce by, and I notice on this diagonal, they're both even, so I divide out of 2. That gives me 2 divided by 2 is 1, 4 divided by 2 is 2. So then I multiply straight across. This is what your brain is doing, 1 times 5 times 1 times 2, and we get 5 halves. If you want to convert it, remember, it's just a division problem, where you're dividing the denominator into the numerator. 2 goes into 5 twice, which is 4 with 1 left over, and then we have 1/2 left over, so either of these answers are good. Okay, let's try another one. Oh, I guess I renumbered these. I'll go back and fix that. How about that? This should be number 3. Ooh, wow, that's a big eraser. That should be number 3, and this one should be number 4. Ooh, that's super big eraser. I'm going to have to make that guy smaller. Yeah. That'll be better. Oops. Gotta get my pen back on. Okay, let's do, how about 2/7 divided by 5? So again, step 1 is to rewrite the problem. Because the whole number's in the back, I'm going to take an extra step here to be extra cautious. All right, so now I've got 2 fractions, so then begins the problem. So first guy doesn't change at all. Boy, that 7 looks like it's just the denominator, so there. That's really lame looking, but you get it. Oh, and I did something I shouldn't have done. Uh-oh. He still was a division at this point. This is what happens when I make videos late at night. So then we're going to get that division to change into a multiplication problem. There we go. and then we're going to take the reciprocal of the second number. Now on this one, I look on one diagonal, 2 and 5, nothing. The other diagonal, 1 and 7, nothing. Fraction, 2 and 7, nothing. 1 and 5, nothing. So all I'm going to do is multiply straight across. So my brain's going to multiply 2 times 1 over 7 times 5. And I get 2/35. And that's just a regular old fraction, so there's nothing I can do to change that. And then let's talk about, let's get into a little bit deeper. Let's do a mixed number divided by a fraction. Okay. So first thing we're going to do is take care of that improper fraction. 4 times 1 is 4. 4 plus 3 is 7. So I have 7/4. And I'm just going to write out the rest of the problem. I do too much at one time and something gets left off. So 7/4 stays 7/4. The division becomes a multiplication. And the reciprocal of 2 over 5 is 5 over 2. Dang, but I thought I was going to have something to cancel. 7 and 2, nothing. 5 and 4, nothing. 7 and 4, nothing. 5 and 2, nothing. So I'm going to multiply straight across, which would be the 7 times 5 and the 4 times 2. So that gives me 35/8, which is perfectly fine because this isn't a word problem. Or I could divide 8 into 35. Well, 8 goes into 35 4 times, which is 32, with 3 left over. So that would give me 4 and 3/8. All right, I'm going to do a couple more. Let's do number 6 over here. What if I have two mixed numbers? So 5.5 divided by 2.5. So I'm going to go ahead and convert both of these. 2 times 5 is 10. 10 plus 1 is 11. So I get 11 halves. It's still a division problem because I'm still altering. And then I'm going to do 2 times 2 is 4 plus 1 is 5 over 2. Okay, so I'm going to keep the first fraction the same. Division is going to become multiplication. And I'm going to take the reciprocal or flip the second fraction. Now I'm going to look for something that I can reduce by. Let's see, 11 and 5, nothing. 2 and 2, oh yeah. 2 divided by itself is 1. 2 divided by itself is 1. 11 over 1, no. 1 over 5, no. So this is where my brain starts looking at what it needs to do. And I get 11/5, which is a perfectly good answer. Or I could divide. 5 goes into 11 twice, which is 10, with 1 left over. And the remainder becomes 1/5. So 2 and 1/5. Okay? All right, let's do a fraction divided by a mixed number. And we have 5 and 5/8. Okay, poof. All right, so 3/4 isn't going to change. Let's just keep division because we are going to have to convert. So 8 times 5 is 40. 40 plus 5 is 45 over 8. All right, now we get to do, we're going to keep the first fraction the same, do nothing to it. We're going to change division to multiplication. We're going to take the reciprocal of 45/8 and make it 8/45. Now we're going to look for any cross-canceling. 3 and 45. Well, the rule about 3 is if my number, if I can add up its digits and it's something 3 can go into, then it's divisible by 3. So if I add 4 and 5, I get 9. So 3 divided by itself is 1, and 45, 3 goes into that 15 times. Okay, now I'm going to look the other direction. I've got 4 and 8. Oh yeah, 4 goes into itself once and into 8 twice. So what is my brain left with? I've got a 1 times a 2 over a 1 times a 15. So my answer is 2/15. And you can't do anything more with that guy. Okay, so let's do just a basic one. 8/15 divided by, let's do 4/5. Okay, so we don't need to create anything into a fraction. It's good to go. So we're going to keep 8/15. We're going to change division to multiplication. And we're going to take the reciprocal, or flip, the 4/5, which would be 5/4. All right, let's see if we can find something to cancel. Let's see, 8 and 4. Oh, they have a 4 in common. 4 goes into 8 twice. 4 goes into itself once. Oh, 15 and 5. They have a 5 in common. 15 divided by 5 is 3. 5 divided by 5 is 1. Oh my gosh, I love problems like this where they cancel. So cool. We get 2 times 1 over 3 times 1 for a grand total of 2/3. And there you have it. All right, good luck with this, guys. We'll talk to you later. Bye now.